Okay, shall we make a start? Can you all hear me okay? All right, okay. So, yeah, welcome to the panel for developments in tools, policy and workflow for sensitive data management. Now, this should have been a four-person panel. It is still a four-person panel. It's just you can't see three of the panel because two of them are in Australia, where it's 3 o'clock in the morning at the moment. They've been good and they haven't been down the pub, so that's always a bonus. And my colleague Deirdre, who's in the UK, and I think it's about 6:30 or something, is it now? Something like that. So we have a truly hybrid panel today, okay, but I'm just going to be the one who's fronting it today. So if we move on to the next slide, what I'll do, I'll get this out of the way now because we all have to do a slide about ChatGPT. Now, Arafan Gregory, who I work with on and off, he came up with this yesterday. I cannot improve on this, but now I can take that off the list, and we've talked about ChatGPT, okay. So the way this is going to work, I'm just going to open with a few kind of big picture observations about where we are with the sensitive data landscape. Now, we will talk a little bit about what we mean by sensitive data, but I really don't want to get sucked into a navel-gazing fest about what sensitive data is, or a definitional sinkhole around the differences between confidential data, private data, sensitive data, special category data, the list goes on and on. Suffice to say that kind of illustrates the problem, that we don't have any clear, obvious common agreements about what we mean by sensitive data. But as I say, generally, as a working definition, when I talk about sensitive data, I'm really talking about personal data against which we need to mitigate risk in order that we reduce the risk of disclosure of individuals. That's actually a lot more convoluted than I wanted it to be, but as a working definition, we're kind of talking about personal data. So I'll open up with some general statements about that, and if you want to, I want this to be relatively informal. If you want to react against some of those or kick back, or if you have any questions, we'll do that then. Then we'll move on to, actually, Ryan Perry will go first. He's going to talk about data risk assessment tooling, work they're doing at the Australian Data Archive, DRAT for short. Ryan Perry is Deputy Director at the Australian Data Archive, and he works with Steve McEachran at the Australian Data Archive. So Ryan will tell you about the DRAT tooling. Deirdre, my colleague, who's the Data and Research Technology Manager at the UKDA Service, she'll walk you through some really kind of interesting work we've been doing on machine learning and how we can actually get machines to do some of the automation around categorizing the sensitivity of individual variables. So there's a lot of exciting work happening in this space at the moment. Okay, so let's start with the researcher, and we don't often do that. At IASSIST or RDA, a lot of presentations I see usually start with, we've got this great piece of platform engineering and we're going to release it next year and it's the next piece of vaporware. But sometimes we don't go back to first principles and say, why is it so difficult for researchers to get hold of, well, I'm calling that control data here, but essentially more sensitive data, more personal data. Why is it so difficult? Because our researchers tell us that. And some of this is based on an ONS session in the UK where we had direct researcher feedback and, what are their pain points when it comes to accessing controlled and secure data. So the application process essentially takes too long. Now, there are many reasons for that, some of which we'll go into. But, we've got real-world use cases where a PhD researcher has applied for data and they're still trying to get hold of it 6 or 9 months later. And then they escalate it up to their professor, who then escalates it up to our funder in some cases. So the whole thing is, it takes too long. It becomes too complicated. And, there are many, many things we still need to do to make that better. When we look at application forms, feedback we got from researchers is there are too many questions. Some of these questions are not really obvious why they're being asked these things. We're not always clear on the repository side why we're asking some of these questions. It's just established convention. So that is ripe for consolidation and also standardization across the board. There's no single unified researcher accreditation system. Now, there kind of is a researcher accreditation system in the UK. People have an accredited researcher number, but it's not always leveraged by each repository in the same way. although it's 2023, when we make them give us an accredited researcher number, we go and check with ONS, who maintain this accredited researcher scheme, and we literally download a spreadsheet once a month. Now, this is 2023, and we're downloading spreadsheets to check these kind of numbers. So, you know, just in terms of simple engineering, there are things that we could do. Now, this is an international problem as well. Now, ICPSR have done some work and introduced, you know, the concept of a researcher passport. Now, I would like to see that really uplifted to a supranational level. So that kind of pre-authorization, rather than having to fill out the same information every single time you apply for data, you know, just to have some credentials. You know, we can get into the, yeah, let's put this in a blockchain kind of airy-fairy stuff later, but, you know, the basic principle of having some simple authorization credentials that you could reproduce, like a researcher passport, that's a really important thing that can improve the researcher experience. The metadata isn't always good enough. Now, one of the main problems we have with access to data is that each repository pretty much defines its own access classifications. They may settle on some broad agreement about open data or control data, but you've only got to look at the way we do things. We have open, safeguarded and controlled. If you go across to open air, they'll be talking about restricted access or open access. If you go across to ONS, they'll have a different set of access classifications. And these have evolved over time and in a fairly ad hoc way. So some standardization there. So when we talk about open data, we know precisely what we mean, and that requires additional information. It requires additional metadata. So that's, you know, a lot of this is an upstream metadata problem. So project applications have to refer off to data owners every single time. So again, it's this pre-authorization principle. Why, you know, I can apply for 6 projects over a period of time with the same data owner. Every single time I'll have to get explicit permission from that data owner to run the project. You know, in instances, I don't know if this has happened recently, John, but we've had data owners who appear to have died in the meantime. You know, so I mean, silly things like that need to be cleaned up. And almost every trusted research environment has a different set of requirements when it comes to technical access. We, for instance, have been asking for IP addresses from researchers. Others may not. Others may insist on multi-factor authentication. Others may insist that you have to be based in a particular location. So all of these things are idiosyncratic to each repository. So the message is really more metadata and more standards. So we look at all of these things and we just go, yeah, well, just automate it. You know, what's the problem? But automation is easier said than done. Now, there are a lot of things that can be automated around workflows. I mean, you know, there's nothing new there. But automation actually requires an ecosystem and a framework behind it to make it work. So as I've already alluded to, we need better, I mean, much better upstream metadata. The way that we assess the sensitive data at the moment, and the end product of that is to say, you know what, this is sensitive. Now, if you want to look at the granular reasons for that and the provenance of that decision, it's not there. Now, that's not to say that work hadn't been done in the back office to assess the risk of that and to apply anonymization. But if you're looking for structured metadata about what was done, by whom and why, that is largely missing. Now, for machines to make intelligent decisions about routing either into a trusted research environment or not, or to say this variable is sensitive, but you can have these other variables, all of that needs rich upstream annotation of metadata. And the way that has to be done is going to be through machine learning. So, you know, I referenced ChatGPT, but I can't entirely escape the concept of machine learning in here rather than AI. So we need to accept that our metadata is just not good enough to support the kinds of interoperability and workflows that we'd want to do for more sensitive data. We also need cultural change and institutional investment in skills as well. We kind of reach an inflection point where it's becoming clear that the sometimes asserted split between non-technical practice and technical practice in digital repositories is becoming not just fuzzy, but largely not helpful. You know, to reach a certain point around metadata annotations where you classify this as a technical inverted problem, this isn't really really helping with the mix of skills that's actually required to do this. For a national digital repository where data is your core asset, everyone is technical. It's just largely a matter of degree and specialisation now. So there needs to be some acknowledgement that there are going to be more specialised roles, and not the generic kind of data stewards will solve all of this, but really specific job descriptions that are advocated by organisations. In the UK, there are things being proposed like TRE operators, which you'll know about, John, that came up recently. So these specific job descriptions that are more geared towards what people are actually going to be needing to do. I mean, this is anecdotal, but I read something a few weeks ago that 98% of jobs that currently exist didn't exist in 1960. So, jobs and job specialisations have to transition all the time. And I think we're at a point with managing sensitive data and those processes that we need to think about what jobs are currently required and better target those. And on a similar theme, really, a transition to a security and risk engineering mindset. There's a lot of conversation in the UK at the moment about whether we should just throw everything into a trusted research environment, i.e. quite seriously, no one will be able to download data anymore. Now, your first instinct is to go, that's absolutely mad, but not necessarily. We need to articulate why it's important for researchers to be able to download data. And having done that, we needed to be able to demonstrate at a granular level why what we currently call safeguarded data or end-user license data, which is minimally disclosive, we need to define the risk in a much more granular and structured way. It's not enough to say we're a trustworthy repository, you don't need to worry, because we push this data out and we know it's disclosive, it's just a matter of degree. We make users sign agreements to say I promise not to be naughty, but if you've got a cyber security head-on, you think, wow, that sounds a bit 19th century that we're just going to have all these kind of gentlemen's agreements and researchers will promise to behave. So that needs to be much more robust and structured in the way we move forward. And Steve will talk about this later. We need to look at this as a whole life cycle problem. When we talk about sensitive data, it's not just a curation issue or annotating data. It's right from the creation of the data by the data owner. They need to understand how sensitive their data is. As it goes through the curation pipeline, we need to annotate that with richer metadata. We need to understand how we grant access to the data. The way that we define access routes, access workflows are fairly analog and pretty fuzzy at the moment. And also, when we give access to the data, that's not the end of it. That's only the start of it for the researcher. So through that 3-year journey, typically from access to the data, we really need to think about how we define in more structured and deterministic ways what the user can do with that data. So just a broad brush kind of set of themes, and I'd say I want this to be an open forum, so have a think about some of these. Are there things we're kind of missing here? Workflows, we need to think about how we get the data in, how we do output checking, which is a notoriously kind of difficult subject, especially when you start thinking about potential automation. Forms and metadata. Why don't we have just a standard application form? Globally, and I'm not quite serious, for project application forms, why don't we define a core set of metadata that people require? And if there are local extensions that are required nationally for particular regulatory or legal contexts, that's fine. But why is every repository creating its own idiosyncratic form? There has to be an opportunity for standardization there. There are new ontologies emerging now which can support some of this structured data. We still really almost unconsciously accept that licenses and rights management are prose artifacts. Depositor licenses maybe 3 or 4 sides of dense legal prose. That can actually be disaggregated and marked up in machine actionable language, but none of it is really happening yet, maybe because people aren't aware that it can be done. We also have things like data privacy vocabulary, which has come out of the W3C, which was released last year, which allows you to annotate personal data categories, consent usages in a very, very specific and machine actionable way. and data use ontology, which describes the things you can do after the researcher has gained access to the data. So these are all interesting and, you know, exciting new ontologies that can support some of the metadata that in turn is necessary to support workflow automation further down the line. I think I've talked about access classifications being a kind of bespoke, you know, repository by repository set of classifications. You look at something like the CESDA data access policy in Europe, which was launched, you know, with a little bit of a fanfare, but it comes down to 3 random labels. You know, it just doesn't. It's of no use in automation pipelines. So when we talk about risk, we need better granular structured metadata around that. Again, open, safeguarded, controlled, or open, you know, semi-mediated, you know, all of these classifications are not really useful, repeatable classifications. We need to look at how we store the data. You know, a lot of data is maintained on file-based systems. We need to think about more database-driven systems where we can annotate structured metadata there. Standard specifications for infrastructure. Now, in the UK, there's something called DARE UK, Data and Research Environments, which is looking to build a standard architecture for trusted research environments. Now, that's looking at it purely through an infrastructure lens and doesn't really talk much about the data. So, you know, referring back to this proposition that this is a whole life cycle problem, you know, I'm going to use that word holistic, which I hate, but I mean, it really is a holistic approach that's required to look at this, you know, not just the data, but the infrastructure as well. So a lot of the tech is there and emerging. You'll see from the following presentations that there's some really cool work being done on diving down to the variable level and working out how we, you know, start to begin automating real-time disclosure assessment. But, you know, some of that needs to be done, but it needs the policy and governance framework around it too, and everyone needs to come along with the ride. So, and all of this before we even start talking about federated infrastructures, which is a whole separate class of problem as well. Okay, so I'm going to stop there just as a starter for 10. So if anyone's got any kind of thoughts or questions they'd like to ask now before we move on to the presentations. Yeah, go on. Oh, sorry, the microphone, yeah.
Initiatives that you know of that are taking care of this, or would it be something for big
well, I mean, this is one of the things I'd like to open up the end.
Okay.
There is something, and you'll know, Hilda, called the Cross-Domain Interoperability Framework, which is an initiative. I mean, sounds like I'm doing a sales pitch now, and I'm really not. Okay, but there are bodies who are looking at this and are interested in it. There's something through CoData. And I think there's going to be an event on Friday to talk about that a little bit more. But we're looking at really, you know, defining, you know, what is the kind of minimal metadata to enable interoperability. And rather than reinventing the wheel, say, why don't we just accept there are certain standards that people are using out there, you know, for discovery. We have DCAT and schema.org, for example. For provenance, we have PROV. For structured data, we would have DDI, CDI. And in this space, which is a relatively immature space compared to discovery, everyone likes discovery, you know, because it's easy. So when you look at any fair project, you know, there'll be a lot of conversation about discovery, a lot less about some of the hard problems around access. But, you know, that is improving, and we are talking about things like ODRL, DPV, and GEO. But, yeah, that CDIF is there. But, you know, how do we do this at an international level? Because, you know, data is global, and the European Open Science Cloud and FAIR, obviously, we're looking at this from a Eurocentric perspective, but why does it stop at Europe? You know, why can't a researcher based in Philadelphia access our data much more easily in Colchester? Now, yes, there's a whole legal and regulatory context around that, but, you know, what kind of bodies, what kind of, you know, government or national apparatus will we need to engage with to make that happen? So, you know, that's I don't have the answers for that, but, you know, thoughts on that would be appreciated. Okay.
Okay, thank you very much.
Okay, so we'll move on to Ryan Perry now. Oh, sorry, I haven't got my glasses on, so...
Felix Ritchie, University of the West of England. I'll just say, yes, Darren's articulated this very well. So tomorrow morning we'll have a session where we'll be talking about what the main social science funding body, the ESRC, is going to be looking at to try and resolve some of these issues. So hopefully tomorrow we'll have a bit more of a follow-on session, I think.
Yeah, that's great.
I believe we have online questions. Do you want to save it by the end?
Yeah, can we save those till the end?
Okay.
Yeah, I think we're to time at the moment.
Yeah,
So
just make sure all the online attendees know. All the online questions will be answered at the
okay.
end.
So can I hand you over to Ryan Perry now, who's Deputy Director at the Australian Data Archive. Apparently there's a tech guru at the back who's going to make this all happen seamlessly. So Ryan's going to share his slides. Are you there, Ryan? It's like Eurovision, isn't it?
I think every co-host can share automatically.
Okay. So Ryan, you're on.
I think I see Ryan's slide.
Okay.
At least the online attendees see, but in this room.
Okay, I think that's working now. Hi, Darren, is that coming through in the webinar?
Yeah, I can hear you fine.
Okay, awesome, thanks. Yeah, so hi everyone, and thanks so much, Darren. My presentation is going to include an overview of risk assessment for data privacy as part of an archival process for storing and sharing social science data. I'm also going to be introducing a web-based tool that we've been developing at the Australian Data Archive that's designed to support and even automate some of that risk assessment process. So data repositories, just like researchers, are governed by privacy legislation in terms of what we are legally allowed to share. In Australia, it's called the Privacy Act, and as just sort of a brief definition, suggests that personal information is sensitive when it directly identifies a person, for example, by including their name, date of birth and address, and accompanies sensitive information. And there's a wide range of potential categories of sensitive information, including racial and ethnic origin, political opinions and membership with political groups, religious beliefs.
Yeah, Ryan, are you sharing your slides at the moment?
Yeah, can you all see them?
Yeah, we can't see your slides at the moment.
Okay, sorry.
It's all right, I've just accepted this never works seamlessly, so it's part of the cabaret.
How's that?
Yeah, that's great.
Okay, thanks. Okay, sorry. This is the first slide anyway, so we're okay. So again, as you can see now, there's the brief definition of the Privacy Act in Australia that I was describing. And as well as responding to this need to the need to ensure that private information is not shared by data repositories like the Australian Data Archive. At the same time, we have to balance data access and utility for data users against the privacy risks due to sensitivity and identifiability of the data, to try and maximize the value of that data and maximize the utility for the data users. And there's a number of different techniques that we might adopt to do this. For example, data could be modified, so there's a range of options for de-identification and anonymizing data to enable us to share it. Data can also be published with conditional access for better or worse, as Darren was saying. We can put conditions on the access, such as license agreements and restricting the the data access to people with certain credentials and so on, but this doesn't, of course, guarantee complete elimination of risk. And likewise, we can also share the data by first providing a description through metadata that can be made much more widely and publicly available. And this can include information about how people might go about accessing that data. Okay, so there's a little bit of general background. Now I'm going to segue a little bit into talking about our particular approach at the Australian Data Archive. And this is going to include talk about some of the tools that we have in development aimed at automating risk assessment and reporting privacy risk, both for our records internally and for the data owners to help them understand our process. So if you haven't come across the Australian Data Archive before, we're based in Canberra, the capital city in Australia, where I'm horrified to say it's 4 a.m. currently. The archive was established in 1981, so it's been around for over 40 years now. We currently hold about 5,000 data sets from around 1,500 independent studies, and we have about 7,500 registered users. And the archive holds a wide range of data types, loosely defined as social science research, and these include some national election studies, opinion polls, panel surveys, census information, and many other sources. And at the archive, we adopt two main strategies for managing sensitive data. These include, as I've mentioned briefly, the applying access conditions using license agreements with both owners and data users, and providing metadata through our online catalog. The other strategy revolves around the manual processing by our archivist teams. We currently have 4 full-time staff members working on data processing, which includes the risk assessment. And to support this rather labor-intensive approach, we have been developing a suite of scripts using the software R to help automate and even standardize some of this processing work. And this, of course, is not just for the sake of the archivists internally, but also as intended as a tool to help researchers and data users understand what we're doing and the importance of data privacy, and ideally even to work as a bit of a self-service tool, so that people might pre-process and understand the risks in their data before they've even submitted it to us or to other repositories. So in terms of that risk assessment using R, so just to provide a little more detail here, we are reading the data into R scripts, and these produce markdown output, so human readable, editable Word files with tables indicating where there might be identification risk, and we're using the script itself is using keyword or key term searches to flag potential direct identifiers, like I say, name, address, postcode information, for example. And then the user, the archivist, usually can then use the markdown output to confirm whether an identifier is true. Unfortunately, one of our limitations there is that there are many false positives. Likewise, the script is also looking for indirect identifiers. So this means when information might be combined to identify someone. So if you have a lot of unique demographic information plus some very fine-grained geospatial information, it might be possible to re-identify someone from that information. And just quickly, the Markdown is also automatically detecting some data quality issues, for example, missing labels, names and labels that might be too long and truncated by some software. And on top of that, the archivist is still required to manually assess sensitive data on a case-by-case basis. Likewise, we're still required to assess any qualitative or open text responses and other work like naming and labeling consistency. And so I'll move on to talk about the risk assessment tool that we've been developing, our web-based app. And this is mostly going to focus around just the direct and indirect identifiers in the data. Okay, so just a quick look first. This is an example of our Markdown output. So this is just an example of how the syntax detects and reports on some direct identifiers. So you can see at the top there some examples of our key term that it's looking for, including name, phone, longitude and latitude information. And it provides us a list of variables with the automatic keyword. So a list of variables that include those keywords. So you can see we've got a lot of variables in here that have something to do with the participants' names. And then there's a couple of columns where the archivists and the data owners can agree on what to do to address the possible privacy risk in there. But I'll move on to talk in a little more depth about how we're trying to deal with indirect identifiers. So again, this is where survey responses can be combined to potentially identify participants. So it takes a little more work to determine where the risk might be amongst these combinations. And just as a little bit of illustration, this is a pretty well-known example these days, and pretty relevant, I think, to the audience today. That's something like 87% of the population in the United States are unique, based only on 3 pieces of information: their zip code, gender, and date of birth. So you might want to have a think about which databases you're in that include all of that information, and what other sensitive information might be in there that's potentially identifiable. So this now is the first page of our web-based app, our data risk assessment tool that's powered by Shiny. Okay, and the aim of this app is to help visualize privacy risk that arises from combining responses across variables. So in this first dialog. The app is showing us the variables in a data set that we've loaded into it that might be candidates for indirect identification. So this is largely known demographic information. So you can see on there we've got examples that include education level and occupation, as well as geospatial information. So there's a few different variables selected on there that have something to do with postcodes. And the nice thing about this dialog is that the app is automatically flagging what it thinks might be identifiable information, but the user has an opportunity to go through all of the data and use those checkboxes to add or remove anything that they think add any variables that they think the app might have missed, and deselect any any false positives. And once you're satisfied that you have selected all the possible identifiers, so all the demographic and geospatial information, you can move to the next screen in the app, and this screen gives us a visual indication of the possible privacy risk that has emerged from combining these from any combination of those variables. So you can see on the left there, you can choose which of the variables you want to combine, and then when you click show, it'll give you a list of all the response categories in each variable, and show you in that final column how many times in the data those particular combinations appear. And if it appears, in this case, it's 3 times or fewer, then we consider that a potential identification risk, just because that combination is unique in the data. And something nice about this is that you can also see the combinations themselves and determine for yourself if these are real risks or not, based on the sort of the subjective content of the information. The app in the next screen also gives the user a mechanism to try and address some of this risk. So one of the main techniques that we might recommend is to combine some of these categories. So if we've got some of the occupation categories with very low frequency of responses, we might combine those together into, say, an other category. So that's what's happening in this dialog here. We get a histogram to immediately see the frequency of each occupation category there. And this little dialog on the left is where you can select each of the categories that you want to combine together. And then this is what it looks like. So I have combined some of those low frequency occupation categories. You can see that that sales workers, machine operators, and so on have been combined with other. I've also combined some of those age groups into 10-year groups. And you can see that this has dramatically reduced the number of unique combinations in the data. And you can go and have a look at those and decide if you think that they might still be identifiable. So, for example, there's only 2 people in this sample who are professionals that are less than 20 years old. So depending on who your sample is, you might say that still carries some risk, and you'd go back and recombine those age groups, let's say, into even broader categories. Okay, so So that's a very quick look at how we're using our risk assessment tool to reduce risk by recategorization. A second technique that we've got in development involves suppressing the responses themselves rather than the categories to try and remove, again, those unique combinations of responses. People might have come across this K anonymity approach before. K just refers to the number of times each combination appears in a data set. So if K is 3, then the data have been generalized enough that there are at least 3 sets of every combination of responses. So there's nothing more unique than 3 combinations. And so our script can identify combinations of responses, as you saw before, that appear less than 3 times in the data. And in this particular option, the tool is able to recode one of those responses as missing to eliminate that particular unique combination of responses. And furthermore, to try and maximize the gain in anonymity and minimize the amount of the suppression that's required, the tool is able to choose the response amongst the combination of responses that appears least often in the data. So the most rare, it's able to eliminate the most rare combinations of responses.
Yeah, it's 2 minutes, 2 minutes, Ryan.
Okay, thanks. Nearly done. So I'll just show you this example really quickly. So this is a sample of unique response combinations in a particular data set that the tool has identified as needing to suppress the education response. And here's an example of the markdown output that it provides us, showing the change before and after suppression in the frequencies for education levels in the data. And this is useful, so you can go in and see just how much the suppression has impacted your data and determine if this is still an effective way to address the risk. All right, and just to wrap up, so some of the future directions, what we're working on now is trying to develop key terms for detecting not just identification risk candidates, but also variables that reflect sensitive data. And the idea here is that we want to include this in the decision-making process to emphasize that de-identification itself might not be sufficient. And for example, here I've highlighted the CARE principles to suggest that publishing culturally sensitive data, for example, still needs to adhere to principles such as collective benefit and responsibility, which still need to be considered, even if you might have fully de-identified the data. The other thing I'd like to highlight at the end is that I mentioned briefly that one of the shortcomings of our app so far is the amount of false positives that get thrown up from using this key term or keyword detection approach. And so something we're working towards there is to ensure that our data risk assessment tool records our decision-making process, so where we deselect false positives and select identifiers that the app hasn't found. So we're aiming to record all of those manual decisions made by the user and hopefully working towards developing a training data set for machine learning. But I will be getting ahead of myself to go into that, so I'm going to leave that to Deirdre's much more considered take in the next talk. So please get in touch with me if you're interested in hearing any more about the work we're doing here with data risk assessment, or if you're interested in trying the tool for yourself. We have a GitHub repository where the syntax is available for any users. And otherwise, thank you very much.
Okay. All right. Thanks very much, Ryan. Okay, thanks very much. We'll pick up questions at the end because I'm conscious of time. So I'm going to hand you over to Deirdre Lungley, who works at the UK Data Service with me. She's the Data and Research Technology Manager and has a team of data engineers doing some really exciting stuff on machine learning for sensitive data. So Deirdre, you're on if you want to share your slides.
Hi, Darren, can you see that?
Yep. That's all good.
Yeah. One moment. Great. Thank you, Darren, and thank you, Ryan, for that talk. It's interesting. We're clearly not the only ones taking a fresh look at our disclosure risk analysis procedures and exploring new ways of supporting our depositors, curators, and researchers in this area. We're taking a slightly different angle on this. We're exploring the potential for real-time disclosure risk analysis of data sets built on the fly. So I'm not going to spend too much time on the screen because my colleagues, Darren and Tom, are going to go through this in more detail on Friday. But what we want to show here is the fact that this data product builder, no matter what resource is chosen here and what's linked and filtered, before we allow the researcher access to the data, we run some disclosure risk analysis using some STC micro functions. And in this case, for the demo, we've put together some. We've synthesized a data set, what we call our teaching data set, and we've linked it with the index of multiple deprivation. And this has come up with 5 what we call key variables, or as Ryan's called indirect identifiers. And what happens then is that we run these combination frequencies. So according to the UK Office of National Statistics, when dealing with microdata, we need to look at 2-way, 3-way, 4-way combinations. So we run those, and if we have violations, similar to Ryan, we're looking for sample frequencies of sample combination frequencies of less than 3. We then go a step further and have a look at the population frequencies, so the combination population frequencies, looking at census aggregate data, and if we then still have a violation at that particular at that point we look for frequencies below 5, and if we have a violation, we then feed all of the key variables back into an STC micro function called pseudo2, which tells us which is the variables contributing most, and we then offer a mitigation. In this case, moving from it's the occupation code, which is it's a 4-digit occupation code, which is the most is contributing most to risk, and we using a kind of using the hierarchical ontological structure, we go up to the broader concept of the occupation minor group, and calculate recalculate the sample frequencies and the population frequencies for that. If the researcher is willing to accept that change, we we rerun these combination frequencies, the two-way, three-way, four-way combinations, and we iterate around like this until there are no longer any violations. So you can see that this is quite an ambitious thing to try and achieve, and there are several dependencies. I won't talk about the identifying the key variables for the moment. I'll just quickly talk about the other three. So the next one of these is the fast computation of the combination frequencies. We've been quite successful with that, and I'll do a couple of slides on that next. Another dependency is the storage population frequency for the key variable combinations. And we're, we have some of these, but we need to get the full range of these. So we're hoping to liaise with the UK Office of National Statistics to increase the number of combinations we've got. And then it's also dependent on us having these hierarchical conceptual structures. So for example, at the moment we have the SOC codes, the occupation classification codes in an ontology, which allows us to go the broad, from broader concepts and down to narrower. So just to, I won't go through this in much detail, but just to explain what we've done with, in order, why it's important to improve the computational performance over the vanilla STC microfunctions. So we've achieved a 30-fold performance over the basic ARM based on using some bit mask manipulation in C++. And just to give you an idea of what we mean by that, so we've run the quarterly labour force survey through one particular wave of that, 96,000 rows. We've identified 10 key variables, and we've realised we want to do 2, 3, and 4-way combinations. That's a total of 375 permutations to check. We have to calculate the bit masks. It takes 5 seconds, which can be done offline and stored, and then it takes 15 seconds with this method to iterate around those 375 permutations. So Darren and Tom will talk a little bit more about that on Friday. But this, this makes this makes this on-the-fly risk analysis possible, whereas with the existing tools we had, we didn't have that option.
Yeah, and if I can just add there, Deirdre, I mean, that's on a half-decent laptop, and so imagine what we could achieve when we throw this at a real high-performance computing infrastructure. Yeah,
exactly. I think we stated there it was on just an i7 12th generation standard 12 gigabytes. Okay, so but going back to our key variables, and the key to all of this is knowing what the key variables are. What are the potentially disclosive variables? And we decided to explore machine learning for this. Now, in previous iterations, at the UK Data Archive, we've had a SCOS Hazard project which has looked at machine learning for variable annotation, but then we looked at quite a wide range of surveys, and we looked at the entire, I think there were a few hundred concepts. So we've decided to do something a little different this time. And so, first of all, what exactly are we trying to achieve with the machine learning, with this variable level annotation? So we need semantic tagging for resource discovery. So I'll show you what I mean in the next slide. But ideally, in order to make this data product builder possible, we need to know exactly what does the community recognise as key variables as being potentially disclosive. So this is our data product builder at the moment, and we allow data set selection based on concepts. So in this case, all we need is study level concept annotation, just topical coverage. That we feel isn't we have a certain amount of that metadata already. So what we're more interested in is identifying key variables. And when we were looking at this subject, we explored the UK anonymisation framework, which was done by Mark Elliott and his colleagues up in Manchester. And they've done quite a lot of work on this. And so they talk about indirect identifiers as being any attributes or more likely combination of attributes that are likely to be unique for at least some individuals in your data set, but more importantly, enter the population. So that's the key thing. And he looks at a fairly innocuous set of three-way combination. So that here we're talking about age, marital status, and a geotag, and a geo variable. So, and in this case, if a data set contained a 60-year-old widower living in rural Scotland, that's what they give as an example of a particular context and where these three variables turn out to be particularly disclosive. But we have to, when we're talking about key variables, we were very mindful of what they talk about when they talk about disclosure scenarios. And we're not so interested in the nosy neighbour, but more this idea of the phishing attack, the idea that finding unusual-looking records, and then attempting to find the corresponding individuals. And this means that we have to be continually assessing our key variables. That's not static. As more data becomes available, more demographic and socioeconomic data becomes available, the key variables need to be reassessed. And they give examples of data sets which of data that can be contribute to risk, as being electoral registers, land registry, and even estate agent listings. You can be surprised what you could see from what you glean from looking at houses up for sale. And then you've got things like social media postings, particularly in the case of celebrities. And then the example of key variables, we're all aware of things like address, age, sex, marital status. But we're bounding our problem, and so first of all, with the scope, we're limiting it to what we call our gold standard data sets. So these are our data sets which are currently they have quite a considerable amount of metadata, including things like variable group and variable subgroup, and study level concepts. And then also we're not looking at the entire set of variables. We're narrowing down, and so we're looking here at certain groups. And so this is our initial subset which we're looking at. And so because we're not jumping, because we've got these kind of gold standard data sets which are already manually tagged with variable groups and subgroups, we're able to feed that in as part of our input features, but also we're limiting the model to a particular variable group. So one example, the one we started off with first was occupations, and the features that we're using are and which we've used in the past are variable name, label, question text, and variable group and subgroup. We're also considering using the category, the categories and codes, because when we actually go to assess risk ourselves, we often, when we're uncertain, we actually look at these categories and codes ourselves. And we're using a language model-based framework, Fast AI. We're using support vector machines, and we're using MK nearest neighbor, and we're using a combination of multi-class, and so where we're annotating with several concepts, we're using a multi-class classifier, and then to assess whether something is sensitive or non-sensitive. It's just a purely binary one. But these models are all on a subset of the data set. They don't attempt to try and to do the whole data set in one go. And also they're then confined to a small set of concepts, which makes the entire thing far more feasible. And we're initially working with the Quarterly Labour Force Survey and the multiple waves we've got. and we're extending then to the other goal data sets. With the, we're building in this active learning where we're continually refining the model. And just to give you an example of what we mean by the text and the labels forming part of our training data. So this is from the quarterly labour force survey, and it's within the occupational variable group, and there we've got the variable name, the label, and the label, and then we've got the subgroup and the group, the variable group and subgroup, and you can see they've all been labelled as under the group of occupations, and then we also state whether they're industry codes or occupation codes, and what particular classification system they're using, and whether they're what level they're at. And this allows us then to link these through the conceptual variable, and from that into our SCOS hierarchy, and to be able to identify the broader concept in the case of mitigations. And current progress, so these are the particular groups that we've narrowed down to initially. So as I said, we're looking at the general occupation group, which includes occupations, industry codes, socioeconomic classification and economic activity. We're also looking at, the next group we're looking at is respondent and household characteristics, and that includes sex, age, marital status. It also includes things like household composition, number of children, that type of thing. And then we separate another group which deals with ethnicity, country of birth, language and religion. So we've started off with just within the quarterly labour force survey, feeding in the data into the earlier waves and testing it with later waves. And as you can imagine, within the series, we're getting almost 100% accuracy. And then so currently what we're doing is we're expanding to our additional gold standard data sets, and because as you move to a different out to a different series, the variable groups aren't common, and therefore we're using a binary classifier to classify the variable group. And once we've got the variable group, we're then using a multi-class classifier to annotate with the labels, and we're testing. We're dividing our data set into training and test, and we're continually updating the training data with new data and iterating around. So we've got one PhD student working part-time on this. So, but we are making progress, and we're hopeful that we'll make some steady progress in the next few months. And I'm sure that's raised a lot of questions. I think as soon as you mention automation of something like this, a lot of people will have a lot of questions, and we are mindful that what we're trying to do is quite ambitious. Thank you.
Okay, thank you very much, Deirdre. So, okay. So as I said before, we'll pick up questions at the end. But yeah, some of the machine learning details might not everyone who's not from a developer background might not have got. But the essential core principle here is that we can get machines to very robustly annotate the data, the metadata that is an incredible useful precondition for doing other operations like real-time mitigation of data sets. So, the automation thing, it's not necessarily 100% automation, but it's certainly machine assisted, and it frees humans up to do what they're good at, which is arbitrating on the corner cases. So I'll hand you over to Steve now. We've had a couple of kind of more focused technical presentations, but Steve is going to talk about the IRIS framework, which gives a wider context to some of the problems here. So, take it away, Steve. Steve McEachran, by the way, is the director of the Australian Data Archive, if you don't already know. Okay, thanks, Steve.
Thanks, Darren. Yeah, so I wanted to pick this up really to put this sort of in the broader context of data curation and data integration that obviously that we are involved in, many of us in the community are involved in here. A lot of what Ryan and Deirdre have been really talking about, fundamentally the need to kind of progress our methods for processing and automating the curation work that needs to occur. And I kind of want to put that in the context of a broader program of work that we're doing, a related program, and actually the risk assessment tool falls under this banner, called the Integrated Research Infrastructure for Social Sciences, to sort of give this a sense of why this matters and how driving a lot of this needs to really rely upon new ways of thinking about some of the curation work. Now, it applies specifically to sensitive data, because a lot of the content that we are particularly interested in integrating may have resultant sensitivity that's associated with it, either on the inputs or on the output side. Putting things together makes it more sensitive. But it also sort of lends itself to thinking more about how do we move along our curation processes more generally to reflect the fact that when that, as Darren kind of just touched upon there, machines are going to do the scale, humans are going to do the edge cases fundamentally, and that's really how it ought to be. But why does that matter? Because and this is sort of what we're kind of reflecting on in the IRIS project. So just to give you a bit of a run through here of what we're doing, and and tying that into some of the thinking that's going on here. So IRIS is really an attempt to try and start integrating data sources across a number of data, Australian data infrastructures that exist. So IDA is one of those, but we have a number of partners spread around the country that actually are pretty sound in terms of the services that they offer, but connecting them up is really problematic. They don't talk to each other in a machine-to-machine way. We can't connect the dots between the systems. So we need really an integration infrastructure to allow them to basically enable the alignment integration of those sources effectively. And key to that, strong privacy considerations, confidentiality concerns that come along with that sort of social sciences data. So the result has been Australia a relatively fragmented infrastructure landscape for social science research. And what IRIS is trying to do is saying we're in the first stages of this, a series of pilots to see, well, what happens when you try and connect the dots between systems more effectively? So we put this in the context of essentially a research process, and this has various foundations for it. This is a researcher workflow, but it's also, for those who like this sort of thing, a business process model. Really thinking about, well, where can we put interventions in place to connect the dots between some of the infrastructures that exist. We stayed away from the analysis environments, and if you think about a bit about what Deirdre and Darren are doing, they're really feeding things into an analysis environment. That's really the domain of the researcher. Let researchers get the data to where it needs to be for analysis. We're interested in how do you get the data to that point, and what can you do prior to that in the work, in the research workflow that might enable some of this streamlining to occur. There's a series of projects that work packages that we're actually doing. But IRIS is also intended as a series of integrated and integrating services, and I put a bunch of acronyms in here. But fundamentally, as I say, each of those work packages is about some sort of intervention in a stage in the process to try and see what we can do to enable that better integration to occur. So there's a vocabulary service, there's a data curation service, which is the CARDS project. There's a connecting to survey data infrastructure about how we collect survey data. And then, particularly a spatial data integration service connecting spatial aggregate data to individual unit record data. And so demonstrator projects actually looking at how we can take advantage of those in particular research domains. And one of those demonstrators, in fact, is a sensitive data project itself. In particular, as we've gone through the project, and it's about 12 months in, and we're moving into a longer term phase in the near future, is what are the key challenges we're having to deal with on the integration of sensitive data? And I can drop the sensitive part of this, and actually, you could include in dealing with integrating data more generally. And this has kind of been reflected already well, actually, how do we define sensitive content, or how do we capture that information about the content we have? How do we even identify that it's sensitive? How do we curate that sensitive content effectively? Now, we've done this, in our domain for a very long time, but we can't do it at scale, and we continue to have that problem. That's really what a lot of these efforts are about. What happens when we integrate sensitive content? Some is sensitive before, some become sensitive after, particularly when you add spatial information along there. That adds quite a lot to the sensitivity. And then how do we manage the access to sensitive content as well? We can come back to that. I'm going to do some other work on the access management processes as well. So, as I say, strong need for metadata and metadata curation and creation. Apologies, to really sort of enable that interoperability part. And as I say, there's various programs that we're involved in at the moment around that. So moving away from F&A and really focusing on INR fundamentally to enable that reusability to occur and enable the interoperability to do that integration. Humans can process and understand that proprietary information. Machines can't. The humans have to focus on those unusual cases, but we can't process the information at sufficient speed. And that's kind of a reflection, really, where Ryan talked about the sort of the manual process and the support process that we have. Deirdre's really talking about, enabling at scale. So what we're moving towards now is, well, how do we start thinking about similarly in upstream processes, how we might support that, and then say, so we have potentially creating metadata at the point of data creation, and curating metadata as it passes through the system effectively through provenance chains and the like. So we've been piloting an initial program to actually explore these issues. So across a series of work packages, we have a vocabulary service, a data integration service, survey production service, and a curation tools, and the risk assessment tool forms part of that curation service, and a demonstrator project for what happens when you try to put it into sensitive data or trusted research environments. All of these sound really nice, but what happens if I've got a lockdown system itself? And so we're actually exploring that at the same time. So a lot of the other efforts of IRIS are really oriented towards the curation and upstream workflows, and then look at the demonstrators who are applying those workflows to particular research problems or in particular contexts, and that's the University of Melbourne doing that work on the sensitive data, the trusted research environment. Fundamentally, what we've found is really a lot of the integration requirements really have heavy metadata demands if we're going to do it machine to machine. This learning came mostly out of the spatial data integration project, but if you look at a lot of the content, and I'll flip to my next slide. In fact, to do the data integration itself, we really need very, very fine-grained information to enable this to occur, in some sort of automated way. Very, very fine-grained information about vocabularies, about variables, about codes and categories, at a really, really tight domain, and really clearly documented. Inconsistencies or inaccuracies or uncertainties in the system, are highly problematic for enabling that integration to occur. And that particularly it's accumulated when we start thinking about how sensitive might the content be itself. But by breaking it down into those work packages themselves, what we've said is actually we can start getting to dealing with these becoming tractable problems if we can look at who's best placed in the research workflow to allow that to occur. And so by mapping that out to the sorts of metadata requirements we have to support that integration, we've actually been able to kind of figure out, well, where should we be concentrating our efforts for particular types of data capture. So a lot of the metadata creations and curation side actually falls inside things like the survey packages and the curation services, enabling vocabulary services to be available effectively. An example that's given here is the industry classification, similar to the industry classification that Deirdre was talking about in the UK. We're really trying to map that, where's the metadata and the data modelling coming from, and targeting our curation and metadata creation services around that. We'll be feeding that into the next phase of our program. What does it really require? Fundamentally, technical and semantic standards, ideally shared standards, but at a minimum, at least we need crossworks between the standards to occur. And we'll talk a little bit more about that later in the week around the cross-domain interoperability framework that Darren mentioned. They need to be persistent so we can reuse them and know that they're going to be available and effective. They need to be fine-grained. What is this variable? What are the semantics of this variable? What's the sensitivity of this variable? But they also need to be able to then go back to the coarse-grained. I need to be able to connect to the context of the methodology. So by bringing together, various parts of things that do already exist, DDI is well positioned to support some of that. But as I say, in different related domains, similar standards occur. We need to be able to get those to talk to each other effectively. I'll move past this in the interest of time, but a lot of the content we are able to map in already. This is the DDI standard itself. We can leverage things like DDI lifecycle plus sensitivity and privacy vocabularies, the data privacy vocabulary that Darren mentioned. The data use ontology is one coming out of the health sciences and the elixir program in Europe. So some of these standards are already foundations that we can draw upon. We can leverage existing services to be able to connect into those systems, and we're for example picking up Collectica to start providing those registry and persistence services that we need, and connecting into the metadata requirements that are there. What we've been able to demonstrate so far is actually we can do a fairly good job of moving content between those different stages in the life cycle. So we're able to move from questionnaires to archives, things like XML and the DDI lifecycle standards allow us to move between data collection and registry systems. We can move variables into archives. That's a long, we've been able to do that for a very long time. Connecting classifications to vocabulary services proved a lot more challenging. The classifications themselves are often not in forms that are actually machine processable and actually require quite a lot of curation. Our colleagues in the Research Vocabularies Australia, the Australian Research Data Commons, have spent a lot of time trying to extract things, scraping content off the census dictionaries, which should be, machine processable. They really depend upon, a lot upon how are the different services, presenting that information effectively. Access points, ideally APIs, but at least in, standard formats, and the formats themselves, being accessible. And we think we can build the sensitivity, the management of, sensitivity of content into this framework as well, using some of the, the techniques that we've seen earlier. If we can, look at some standardisation work around that. And so, this is kind of another reflection of our model. We've actually done a lot of this effectively. We're able to move quite well between the sorts of infrastructure that we need, and we can automate the flows. Now we need to think about how do we scale within the particular metadata creation locations. So, what are we finding might be challenging? We could probably build into the future, bringing content out of registries into questionnaires themselves, into closed and open source survey tools, from question banks and question libraries are increasingly available, but the libraries to actually implement those are not that they're local, they're not external. So how do we better enable the survey data collection tools to be able to make use of that metadata reuse? We can reuse content between systems. We need to establish provenance change to say where this stuff come from. We need, in the context of sensitive data management, to be able to identify and process sensitive variables and concepts in effective ways, and that ties into connecting the data collection and the reuse through to the already processed information about sensitive concepts and variables. And we need to be able to move it in and out of trusted environments effectively. For those of us who manage those systems, think about licensing, think about data ingress and egress. Those, they work against, some of these requirements. The likely solution is likely to be some sort of, graph or linked data service plus a provenance model that starts to build around that, and the community's already working towards that. But we certainly in a good position to be able to move that into the future. But as I say, really what we're trying to work through in the IRIS program is look at, well, okay, where are those choke points on some of those metadata requirements? What do they mean, and what do we really need to do, and how we, where do we put those interventions in place of the sort that Deirdre in particular has been talking about to enable that scaling to occur? And I'll wrap it there.
Okay, thanks very much, Steve. Okay, so yeah, thanks. So you 3 different presentations there are looking this through slightly different lens. I think we've got some time at the end now for some kind of questions. Now, Steve, I don't know if I could trouble you to pick up on the chat, because I can't actually see it on my screen at the moment and see what we've got there.
Yeah, can do. I've got access to Q&A. I don't think there's active chat, so I think that's we do have the Q&A details there though. So.
Okay, so the first one we've got from Kirsten Dutton at ESRC is, how do we decide who makes the decisions on standardisation? You mentioned the community, but where does the responsibility to compile everything and organise those agreements lie? Okay, now my personal perspective on this is that someone has to decide, and right now I don't know, and that's the essential problem. I think that some of these standards, to be honest, need to be done through bodies like W3C, and I mean that quite seriously. Some people will be a bit nervous about that proposition, but I attended a meeting around about 6 weeks ago, I think, which is about a national data research infrastructure. In the UK, there are moves now to standardise these at a national level, and what I heard from very senior people was that we don't want Soviet-style command and control systems. You know, we're an academic community, and we need, to a large extent, to chart our own course. Now, I couldn't actually disagree with that more. I think it's a little bit theatrical and a little bit histrionic to talk about Soviet-style command and control. I think we need to have some minimum standards. If you write a web page, you will write it in HTML. I mean, that's not technically strictly true, but generally speaking, you will accept that you need to write this in HTML and publish it through HTTP mechanisms. Now, that's not Soviet-style command and control. That's a global system that works. And we're in the same position here to a large extent. So I think the first thing is to build this at national levels. I think, you know, this is only my personal opinion, and please don't quote me on it, but I don't think the European Open Science Cloud is really going to deliver very much in the next 5 years on this basis. So we need to start looking at this at national levels initially. I mean, I don't know what your thoughts are, Steve, on this.
Look, I think yes, you have to have some sort of standardisation, you know, in order, to say, I mean, everything that I talked on, you know, kind of touches on exactly that. You know, to get systems to talk to each other, you need to have agreements on what what's that shared information that you're using, and that fundamentally leads you, you know, to a standards, you know, oriented model. Otherwise, things are just going to stay disconnected. As I say, you know, our experience, and just as an example, basically shows is, you know, if we don't have some sort of minimum agreement around what things are and how to exchange information, we can't interoperate these systems effectively. You know, and you know, things will just continue to sit in silos. So, in order for that to occur, you do have to start coming to some sort of minimum common agreement. That does lend itself to standards. And as you say, progressively, the more we can use standards that are already in place, the more we can actually leverage on the technology that's been built around those standards as well. Yeah.
And I think an important principle as well, start funding projects that deliver production systems that do something and add value. You know, I don't mean to go on about Europe, but a lot of projects, the sole deliverable, I'm involved in a couple at the moment, the sole deliverable is a white paper. at the end of it, that doesn't add value for researchers and takes us no further forward. Because if you build stuff that works, you don't have to force the standard on anyone. If you build production systems that add value to the researcher, people will just adopt the standard because it's delivering something that works. And this is how the web came to be. No one up front prescribed HTML, HTTP. It grew organically because it clearly worked. And that's in the nature, and I'm thinking about you, Kirsten, at the moment, about which projects you choose to fund. Fund projects that deliver not vaporware or propositions or jam tomorrow, but real working proof of concept infrastructure that we can build on. So, rant over. Okay, so can we take one for Ryan from Stephen Kramer? Could you please give some examples of the many false positives, in inverted commas, that the data archivists encounter from the risk assessment slide you showed?
Yeah, sure. So I read that before. I was trying to think of some of the common examples we find. I think it's mostly an issue of sort of striking a balance between having broad enough key terms, right? So using truncated key terms to capture as many issues as possible, but then finding that those terms, appear in lots of words. So, for example, I just found one. So we use to find any mention of longitude and latitude, we're using truncated terms like LATI for latitude, but that's in the word relative. So if there's any questions about your relatives, it's going to flag those as well. And I think maybe the other good example is that there might be lots of questions that sound like they are about sensitive information, right? So like do you have a fixed address? Yes or no, so it's not sensitive, right? Because it's just a binary response, but it would be flagged by our system because it mentioned something about someone's address in there.
Okay, all right, thanks, Ryan. Okay, and an interesting one, which is why are we not using standards currently? Now, there are many reasons for this. I think I'd refer back to my previous answer because there aren't clear incentives in many cases. There are certain smaller communities. I mean, I'm part of the DDI Alliance, which is very invested in producing and working with standards. But I think across the board, there are no shortage of standards out there, but there are not enough production systems. I think there are lots of propositions and research about what we could do. But, I'm thinking about the European Open Science Cloud again. I think we're not producing enough production systems that give people clear incentives to adopt the standards. So that's a generalised point, but I guess it's a generalised question. So, I mean, Steve, I don't know if you've got any thoughts on this as well.
I'll touch back on the point you were kind of making earlier, Darren, about production systems. I think the best standards you don't ever see, in fact, what they are. The production systems actually are embedding the standards inside there. So say no one's sitting there and reading the HTTP protocol and and the like. But they're sitting behind pretty much every technology that we're looking to use on the web. So as I say, the standards are there, but as I say, we don't always have to be explicit about them. We have to support them at a different layer in the ecosystem that we might currently be thinking of. But that does rely upon those tools and systems, services being in place, and that's the point at which those standards, actually need to be adopted. That's the group that's going to enable, better standards adoption, to actually occur.
Okay.
We have a hand up as well, I think, Darren, online.
Okay, yeah. I mean, I'm in a slightly awkward position. I haven't got my glasses on, so who's got the hand up?
Carla online,
believe
I think.
We need to unmute her, or we decide to how to come. Yeah, so I think as the technical helper in this session, I would let all the online attendees know we probably cannot chat with all of you. So if you really want to ask your question, you can send it to the Q&A, and so that everybody can see and answer. thanks a lot for your patience and enthusiastic participation.
Okay, so have we got any other questions online?
Do you want to take one in the room?
Yes, I could do.
And
Have we got
waiting
any
for
from
the
the
online question?
Have we got any from the floor? Hilda.
Yes, you said, Darren, that you think the best way is to do this through W3C. And how do you see that process could go? Who would kind of initiate it, and what would be the way forward if it goes in that direction?
As you'll be, I mean, I do know Hilda, but as you'll be aware, certain standards bodies like the DDI Alliance have liaison points with W3C. I think those initial contacts just need to be made. You know, those can be water cooler conversations, and just to initiate those exploratory discussions. As you know, Hilda, we've been looking at making DDI an ISO standard, for instance. But, you know, W3C, I'm not suggesting it's necessarily the best way, but I think there have to be, standards need to be designed and recommended at a higher level than local funding bodies. You know, within the SRC at the moment, you know, we're the UK Data Service, we deal mainly with social science data. Our stable mates, if you like, in SRC are HDR UK for health, ADR UK for administrative data. We can't make this stuff working within our own local domain because nothing is coming from a higher level. And again, you know, this isn't Soviet-style command and control. It's kind of national coordination. So I don't want to fall back on the trope that, you know, this is super fragmented and super siloed, but it is. And there was a recent report called the Goldacre Review in the UK, which was very, very thorough in saying, you know, we have to recognise there might have to be some economies of scale if you're going to make this work. You know, we need to move from 160 trusted research environments maybe to a dozen, or, you know, a much smaller number. Now, this isn't news that people want to hear, especially kind of smaller universities who are doing funding on various research. But we have to, you know, perhaps accept that we do need to start thinking about economies of scale here and how this, you know, might more readily be implemented at a higher national and government level. You know, there's this kind of tension between it's a community and a collaboration, but there needs to be some minimal benchmarks that are, I hate to say imposed, but at least, you know, they become gateways to funding. You know, if you want to publish your data on Google Data Commons, you've got to use the right format. If you don't use the right format, it doesn't go on there. And a bit more of that mindset needs to be applied to standards. Sorry, I'm starting to sound like some kind of ruthless dictator, and this is not, I'm quite explaining this not quite as well as I want to, but we have to accept that standards are sometimes not a local choice. You can't have your cake and eat it. You can't say we want to achieve interoperability and not accept the consequences of that. Okay.
Thank you very much.
It does sound like a Soviet-style dictator, Darren, but okay.
Yeah.
I try to unmute Carla and see if Carla wants to unmute herself now and ask the question.
Okay. Spasibo. Okay, have we got any other questions from the floor? I can see a hand there. I haven't got my glasses on, so someone in green.
So, oh, that was way louder. Is there an existing standard that we should be promoting to try to adopt? You mentioned schema.org, DDI. That's kind of, I'm thinking of the XKCD cartoon. It's like, we don't need another standard. We need to decide which standard we're going to push forward.
And
so
there are enough
which
out
one
there.
should it be?
Okay, most people in here are social scientists. In the main, you should be using DDI. I mean, just, you know, you should be using DDI. Okay, if you're using catalogue or you're trying to generate catalogue and discovery metadata, you should look at DCAT and schema.org. If you want to exchange machine actionable provenance information, you should be looking at PROV. You should be looking at something called SDTL. Dan, I'm doing a pitch for SDTL here. Okay, if you're looking at licensing information, you should start looking at ODRL. I'll be straight with you, there isn't a huge uptake on ODRL at the moment, but we need to reach that tipping point where there is. So there are a small number of standards there that you can start investigating straight away. If you're using social science service data and you're not using DDI, start looking at DDI, okay, because there's nothing else quite out there that is as rich and descriptive, to work with social sciences survey data. Okay, so if you want some minimal recommendations, that's where I would pitch them. Okay. So.
So I've been given the mic for another question. I'm just wondering, like, your choice to go for the standard. I see that in RDA and the sensitive data interest group, that Steve, at least among you, is already involved in that, and is that a route a bit more multidisciplinary to
yes, I think on the circuit generally. I mean, we have IASSIST. I think RDA is a bit more focused on domain specific areas. So if you're not part of RDA, I would recommend that you kind of join up. You don't have to travel. You can get. I mean, there's lots and lots of working groups and interest groups there, and I think RDA is probably closest to what I'm aware of as a genuinely kind of global community around these issues. So Steve, I know you've got a sensitive data working group, haven't you, within RDA at the moment?
So fundamentally it's that's kind of where some of those efforts start to come from. There is kind of touch on the previous conversation question and this one, is you need a mechanism to say I hate to say it, actually there isn't one standard, but there are within particular spaces an optimal choice, or a small number of optimal choices. So picking up within a particular domain or a discipline, what is going to be the key one there, and then there is an effort to then look at, well, how do you connect those standards together fundamentally? As I said, we're not going to reinvent the ways of transferring data over the web, but how DDI leverages those existing protocols and standards to connect up to those. That's the efforts of the standards bodies to connect the dots between those. Groups like RDA, say similarly, UKDA and others, the World Fair Project, which we'll come back to this on Friday, in fact, are looking at exactly that as well. How do those standards connect to each other? How do we work across standards effectively to allow that communication to occur in a more effective way? But if everyone's using, they're not standardising within their domain and they're just rolling their own approach, there's just no way of making that tractable. It is possible to move, to map between standards, but it's not possible to map between every system that might otherwise be out there. You've got to have some point of coordination, to actually occur.
Okay. So any more from the floor? I think we've got a final question on the chat. Okay. All right, so we've got one here, what implications would this have on Indigenous or marginalised communities who want autonomy of their data? That's okay. If you want autonomy of your data, then you have to accept the consequences now. You can't have autonomy of your data and want to share your data. Now, I suppose this all comes down, I could take the scoundrel's refuge here and say define autonomy, define Indigenous or define data. But I think I'd like a little bit more context to the question.
Darren, I could probably pick that up. I say I've got a presentation in the next session on this. But autonomy doesn't necessarily mean you lose, a lot of the standardisation doesn't mean you lose necessary control over your data. That's the difference between access and standardisation. If you want to be able to sort of make your data accessible, it's still possible to do so under governance roles that are there. That's a question of managing a governance and an access framework, and there are some good models for actually doing that. But yes, to be able to get, if you are interested in data sharing, some form of integration and standardisation, you know, is needed to facilitate that. So there's, you know, it's possible to bring those two things together, you know, and there are some trade-offs that, you know, that do result from that, but they are not, you know, necessarily mutually exclusive. But you have to recognise what's the purpose and what's the decision-making rules within a given community that you're interested in supporting, and how do you embed those into some of the technical protocols. As I said, I'm talking about one example of how a community is going about that coming up in the next session.
Okay, great. Thanks, Steve. Okay, so have we got any more for any more? I think it's time. Yeah, we're 10 minutes over, I think, aren't we? So, yeah, we'll wrap it up there. But, yeah, thanks for your questions. And I hope that's shed some light on newer developments in this space. Okay, thanks, everyone. And thanks to our presenters.
Thank you.
Recording stopped.